In this lecture, we're going to talk about the basic operations on vectors. Vectors are those quantities which contains a particular direction and a magnitude. Let's suppose that a body A has magnitude of 2 cm and a body B, which is also a vector, contains a magnitude of 3 cm. So what will be the resultant? Resultant is the result of the addition, subtraction or multiplication or division of the two vectors or above the two vectors. The final result is called the resultant. So what will happen if we add these two vector quantities which contains a particular direction? So let's draw it on the scale or the plane. So let's suppose that a body walks 2 cm towards the A direction or towards the west. So we can say that this is A and direction towards, like from this to this, like we have to just B is equal to 3 cm. So we will just draw line that collides from the 2 cm towards 3 cm. So we will just draw a line. So this makes an angle and we have to find the resultant. So we will just make a line from there to there. So how just I had made this plane? So this plane is based on the head to tail rule. So let me just explain what is head to tail rule. Suppose this is the first line or first direction. We have to just place the tail of the second direction or the second magnitude to the head of the first one. Like I have to place the direction showing the A to the direction showing the B. To find the resultant, I had to just place the tail of the resultant to the body A and the head to the final body. Like if suppose we have A and B and C, so I have to just put the head of the resultant to the head of the C and tail of the resultant to the tail of the A. That's how we can find the resultant of that magnitudes. How can we find this resultant of these? We have to just plus the magnitudes. How can we plus that? 2 plus 3 is equal to 5. So 5 cm is the resultant. We can say that in addition of vectors, the magnitude will increase. Like 2 plus 3 is equal to 5. The magnitude is increasing. So we can say that the magnitude will increase. Direction will be same. Direction will be same. So we can say that the definition is in addition of vector, magnitude increase, direction same. Let's talk about the subtraction. The same quantities. Let's first draw the vectors. So first we have to draw the direction from 2 cm, that is called A, and let's draw the second one. It's the negative, like we have to just minus A from the B. The B is minus, the B is negative, so we will just draw it at the 180 degree 3 cm. We have to just pass it to this point. So we will just draw 3 cm like this. And this is B. So how to find the resultant? I have told you head to tail rule. Like this. The resultant is found. How can we just write that? 2 minus 3 is equal to 1. So we can say that in addition, the magnitude will decrease. 2 minus 3 decreases. The direction will oppose up to 180 degree. The direction oppose because the value is to be subtracted. So direction will oppose. As we had taught about the addition and subtraction, in the addition the magnitude increases and the direction remains same. In the subtraction the magnitude decreases and direction just opposes. As like the addition, in the multiplication the magnitude increases and the direction remains same. But there's a condition. If the magnitude is in negative, like -4, so the diagram or the representation will opposes 180 degree as we do in the subtraction. In the subtraction, the magnitude is in negative. That's why we just represent it like that. But in the multiplication, that's in condition that if the magnitude is in negative, the answer will be opposed, or sorry, the direction will be opposed 180 degree. So let's represent it. Let's suppose in a plane, we will just take the same example so it will be easy to understand. Just draw it. Like let's suppose 2 multiplied by 3. What we will do? 2 multiplied by 3 resultant, and that would be our representation, and it will be 6 centimeter, and that's the answer. What if the 3 is negative? What we will do? 1, 2, 3. 1, 2, 3. 1, 2, 3. What we will do? 2. And after that, it is in negative. It will just move like anti-clockwise. And 3. Resultant. 2 multiplied by -3 is equal to -6. And that's the representation in the multiplication. Let's talk about the division. In division, there is also the same thing, but the magnitude in the multiplication increases, but in the division, the magnitude decreases. As the direction, in the condition of the multiplication, if the direction is positive, the answer will be, the direction will be same, but if the magnitude is in negative, so the answer will oppose 180 degree. So as the condition of the multiplication, this condition will also be applicable to the division. So let's talk about that. Here the magnitude will be changed to make it easier to understand. 2, 3. Okay. I will represent both negative and positive here and in the same plane. So let's talk about the 2 divided by 6. Okay. Let's talk about that. Oh, I have to make more. Okay, that's it. 2, then 6. Resultant. What if we divide the 2 from the 6? The answer will be 3. 3 centimeters. That's the resultant. What if if 6 is negative? What we will do? We will just oppose it and like that. Just make an angle and it will become 2 divided by -6 is equal to -3 centimeter, and that's the answer. There are some key points. Scalars are divided, multiplied, subtracted or added, or we can say that operations on the scalar are done by arithmetic laws or arithmetic equations. We just have to solve the scalars by arithmetic, and we just have to solve vectors by algebraic equations expressions. In electric, only intensity is vector, other are scalar. Like electric intensity is vector. But what if electric current? Electric current is a scalar. So we can say that expect the intensity, the word intensity, every electric, the term that contains electric in it is a scalar. The flow of current is same as flow of water. The current is currently or frequently flowing as the water flows. So that's all about the today's lecture.